A majority of our viewers have a lot of experience in local area networking, but not a lot of experience in storage area networking. So this is going to be one of those nuggets that they really pay attention to. Because in the certification environment, it is expected that we have a good depth of knowledge regarding storage area networks and particularly the protocols that are options in those networks. That's the stuff of this particular nugget. Let's jump in. Now, there really is a lot for us to work through in this particular nugget. We'll go ahead and start off talking about the differences that we find between file-based and block-based storage protocols, and we'll walk you through some examples of the most popular of each of these. Then we'll get down and dirty with NFS, Fiber Channel, SCSI, iSCSI systems, and we'll really see what goes on the scenes behind these important storage protocols. Finally, this nugget will wrap up with a little bit of a history lesson. We'll talk about the move from direct attached storage to storage area networks that we have today. Now, some protocols that you've probably heard of before are There's lots of messaging going on between these particular protocols in order for them to do their work. Both of them certainly provide shared access to files that are centrally stored and shared on the network infrastructure, but again, we have high latency and very chatty in their particular nature. Both are suitable for things like Microsoft Office, Microsoft SharePoint, and file and print shared services in a Unix or Linux environment. So these are our file-based protocols that I want you to be aware of. Now, you're probably familiar with the Small Computer Systems Interface. This is a block-based protocol for writing and reading data blocks to and from a storage device that is really excellent for high performance. We actually call this IOPS, which means we're doing many input-output operations per second. In fact, let me write that on screen for you to see. So IOPS refers to the many input-output operations per second that Small Computer Systems Interface can achieve. Now, understand that SCSI can be transported in several ways. I know the first time that I experienced SCSI was with a parallel SCSI cable. Sure, this is how we can send these I/O messages back and forth between the computer and the storage, and we would find this in our traditional PC environment. We have very low latency with the parallel SCSI cable, but the problem is, of course, is that we are limited dramatically in distance. Yeah, we can't have a SCSI parallel cable that spans long distances as we would want in a data center environment. So, there was an invention of a technology called iSCSI, and we'll look at iSCSI in much more detail later on in this particular nugget. This is the transport of SCSI over TCP/IP. It has higher latency and relatively low bandwidth over our gigabit Ethernet LANs, but it's a very inexpensive way in which to do our storage communications. Then there's a fiber channel cable that can be utilized. And this is what we have in a traditional now storage area network. There's low latency, and we have a relatively high bandwidth that is available with fiber channel, and that is an 8 gigabit per second technology. Then a new and exciting technology for the transport of SCSI is fiber channel over Ethernet. We have this in our 10 gigabit per second Ethernet technologies of today, where we literally take the fiber channel communications and encapsulate them in our ubiquitous Ethernet protocol. Obviously, in this particular nugget, and for that matter, in other nuggets of this course, we'll talk in much greater detail about the exciting fiber channel over Ethernet technology. Now, before we elaborate on our SCSI block protocol, let's go ahead and talk more about the network file system, or NFS, a file-based system for storage. First of all, I want you to know that this is indeed a client-server type of situation. So we can have a Unix client, we have a Unix server for the NFS. There is a service that is available on the client issued here on the Unix client in an NFS environment is the mount command. And if this command is successful, if everything checks out, a success error is returned to the client, and that particular resource can now be accessed by the Unix client. And by the way, you probably won't be surprised that in Unix environments, there's an application you can use called an auto mounter. And what an auto mounter will do is mount the file system on demand that the Unix client wants to access, and then go ahead and dynamically unmount the files if they're not accessed within some period of time, normally like a few minutes. Now, once the mounting is successful, the client can now issue file system commands. For instance, the client could issue the ls command to list the contents of a directory. This particular request goes up to the server to the NFSD. That's the NFS daemon that's running on the server, and it's the job of the NFS daemon to go ahead and process these types of commands and return the results. Now, please be aware there are indeed three major versions of the network file system. There's version 2. Version 2 was defined in RFC 1094, and it uses a 32-bit file size. It is state turn our attention to SCSI, and particularly that very common channel, that basic parallel SCSI bus channel, which we talked about. This can be internal to the host, as I alluded to, or it can be external to the host. Notice when we're talking in SCSI terminology, we talk about the host as an initiator, and we talk about the storage as a target. The SCSI half duplex parallel standard comes with some limitations. Notice that we can indeed daisy chain the devices together in this configuration, but that does max out at 16 devices. The biggest limitation, which I alluded to earlier when I introduced SCSI to you, was the fact that the total bus length is going to be 25 meters. So that's not going to really get it done for our data center type environment. By the way, this is shared channel bandwidth, and the bandwidth maxes out at 320 megabits per second. So you're probably not surprised. I want to quickly move away from the discussion of that old parallel SCSI bus, and I want to talk about a way in which we can carry those important SCSI commands, and that is fiber channel. Yeah, fiber channel really became the classic transport for the SCSI payload in the storage area network environment. So you know the deal here. The idea behind fiber channel was to overcome the many limitations, most particularly the distance limitation that we had with the parallel SCSI bus transport. Fiber channel includes a bunch of features I want you to be aware of. As far as addressing goes, no problem. There can be 16 million nodes as far as the addressing system of fiber channel. We can do a loop, kind of think of our classic token ring type of topology, or the modern day switched transport. Now, when fiber channel is organized with fiber channel switches like this, we tend to call it a fabric type of transport. So switched or fabric are used interchangeably here. Host speeds, well, we can have up to 800 megabits per second, or if we're in a switch type fabric infrastructure, we can get up to 8 gigabits per second with this particular technology. Segment distances, no problem. We can go up to 6.2 miles with fiber channel as the transport for our SCSI signals, and there is indeed support for multiple protocols with our fiber channel infrastructure. So let's get behind the scenes with fiber channel. We know we have this concept of an initiator. This would be like our host system. And notice there's a host bus adapter in this system for communicating over the fiber channel medium. And here we have a fiber channel target where all of our stuff is being stored. We have the smallest unit of data, which is called a word. A word is 32A set of frames that are being sent by one of our nodes. Now, obviously, there's going to be some sequences that go on when we're doing a read and write request between these two devices, and that collection of sequences is referred to as an exchange. You can think of an exchange as being equivalent to our TCP session in an IP world. So we have the concept of a frame similar to an IP packet. We have the concept of an exchange similar to a TCP session. Now let me provide you some more details on iSCSI. Remember that transport option that we mentioned? Sure, here we're encapsulating those SCSI commands, data, and status information over our good friend IP. Obviously, this is going to allow our many IP hosts out there to gain access to the fiber channel based storage targets that we might have. This is great because it leverages the tremendous investment that we make in our IP based infrastructure. One thing I want you to be aware of, the test may literally ask a detail like this. It's TCP port 32 60 that provides congestion control and in-order delivery of error-free data in an iSCSI environment. By the way, you know what one of the nice things about iSCSI is obviously it dramatically addresses distance concerns that we might have with the SCSI-based block protocol. Notice that there is the MDS 9222i or the MDS 9000 series device that provide transparent SCSI routing thanks to this iSCSI capability. So I need you to realize that all of the protocols that we've talked about in this particular nugget have really given rise to a revolution in storage, from directly attached storage to storage area networking. You see, in direct attached storage days, we would have devices access storage through a LAN that was directly attached to a particular host. The SCSI protocol would move the block information from that direct attached storage, but there were many, many limitations here. Obviously, one of the limitations is limited mobility. Yeah, in fact, this directly attached storage was often referred to as captured storage, and that really gives us a great sense for this particular technology. There would be limited scalability as well with this particular solution. Efficiency was sacrificed, and this would tend to be costly to scale and very, very difficult to manage. So all of these reasons really pushed us towards the storage area network infrastructure. So in this nugget, we analyzed file-based solutions and we separated them from block-based solutions. By the way, do you recall what the file-based solutions are that we looked at? There was CIFS and NFS. And these really were a kind of stepping stone in the storage infrastructure, right? We originally had the direct attached storage. Then we tried a network file storage approach with our CIFS in Windows environment and NFS in Linux environments. So let me just say file-based approach. And then, of course, the storage area networking approach with its block-based SCSI utilization and the many, many different transports for that, including Fibre Channel. In this particular nugget, we took a close look at the NFS system, Fibre Channel, SCSI, and iSCSI, and we wrapped it all up just by talking about this evolution in storage area networking from direct attached storage to network type file-based systems to the storage area networking that we have today. Now, we're certainly not done with storage area networking topics in this course. In fact, to be honest, we've just scratched the surface. So more great stuff coming up in this particular course. I sure hope this nugget has been informative for you, and I'd like to thank you for viewing.